Question number 6. This question is about electrolysis. So when it is about electrolysis, we'll have to identify first how many ions will be present in the given solution. Here it says molten sodium chloride, so this means there are 2 ions present. Sodium chloride, this means one of them is Na positive and the other one is Cl1 minus, which is chlorine. Is electrolyzed in an industrial process to produce sodium. Figure 8 shows a simplified version of electrolysis cell used. So we've got cell here, we've got positive electrode, we've got a negative electrode. On the positive electrode, there's a gas being produced, whereas on the negative electrode, sodium metal is being produced. Now it says, which is the correct half equation for the production of sodium? So before I answer this question, I'll go back to this section and I'll remind myself that this is positively charged ion. It will gain an electron and it will change into Na solid. This is negatively charged ion. Cl1 minus will change into Cl2 because group 7 elements, they exist as diatomic molecules. Now for it to change into Cl2, you will need 2 of them and they will have to lose 2 electrons. So it says production of sodium, and I already know sodium will have to gain 1 electron in order to change into sodium solid. I just have to see which equation goes in line with this one. So out of these 4 given equations, there's only one equation which is similar to this, which is equation number 3. So the answer is this. Next part says a mesh is used to keep the products of electrolysis apart. Suggests one reason why products of electrolysis must be kept apart. Now in this case, there are 2 products, sodium and chlorine. So if you don't keep them separate, then they will react together again. Right? So to avoid a reaction between products. Next part says, which type of particle passes through the mesh in the electrolysis of molten sodium chloride? So I told you in case of molten sodium chloride, there are 2 ions, there are none other. So we can say atoms, not possible. They won't pass because look here, sodium Na positive will change into Na solid. Here, Cl1 minus will change into Cl2. So if you keep this bit in mind, on the right side, you have sodium atoms. So they can't go through this mesh because from the solution, Na positive will be attracted to the negatively charged electrode where they will gain an electron and they'll change into Na solid, which is atom. Then they will be separated from the setup. So atom is not possible. Electrons, they will move through wires. Ions is the only option in this case, and the answer is this. Next part says aqueous sodium chloride solution. Now this time you have aqueous sodium chloride. So this means now I'll have 4 ions. What are those 4 ions? I'll have 2 due to water, H plus and OH minus, and then I'll have 2 due to Na positive and Cl1 minus, which is due to sodium chloride. It says 2 gases and an alkaline solution is produced. So remind yourself, in this case, chlorine will take priority over OH minus, so it will change into Cl2. Hydrogen is less reactive than sodium, so it will change into H2. You will be left with Na and OH ions, and they will make an alkaline solution. So here it says which 2 ions are present in the aqueous solution of sodium chloride, in addition to sodium ions and chloride ions. We've already decided that it is H plus and OH minus. Next part says name the alkaline solution produced. So in this case, there are 2 ions which will be left, which is sodium and hydroxide. So it will be sodium hydroxide. Last part of this question says explain how the alkaline solution is produced. So you have to explain the process. You should refer to the processes at the electrode. So I'm going to write down anode, which is positive in this case. What happens on the anode? You will have Cl1 minus, 2 of them, and they will change into Cl2 gas plus they'll release 2 electrons. On cathode, 2H positives will gain 2 electrons and they'll change into H2 gas. Now in this case, we can say this is gain of electron. So gain of electron is reduction. Here it is loss of electron, and that is oxidation. So if chloride ions are removed, hydrogen ions are removed, only left over ions are Na positive and OH minus, and they together make NaO